Okay, we're going to use this demonstration to go over the actual hammer frame bar for you guys to see if we can speed up the process. I'm going to go over some tooling here that I'm looking at some selections. For doing the OD contour, I got two options. Number one, I like using our multi-row high pause. We'll do peel milling, where we just take off 30 thousandths per pass. We can get more aggressive, but we'll have to see what the machine will take. And then we can work it way in, or we can take the method with single row working out the Z. The only problem with that is you get towards the final depths of passes, it will actually start leaving a real thin part apart, like the grab or not. If you're right up against the face, it actually doesn't work bad. I'll have to look at the fixturing. It may be an option so you don't have to pay for as many inserts. We'll go over that at a time and look at it in CAM software. The next tool we're using that you're familiar with that we've already used on the Vastamax and we're going to use on that socket project is a 1/2" dipause tetra. We can actually put the female insert. We'll rough out both sides of the pocket. We'll actually use that later for finishing. Just doing over here, we'll use the carbon steel shanks. We're not going to be hanging out that far and be more cost effective. Also, after that, we're going to use a very similar drill to your Comet, but better. And this is something you can use if you don't like this entire process in place of it. To plunge out and drill through a 1/2" web in the center. And then we're going to use a solid carbide shank for finishing. But we're going to review that here in the CAM software, take a little better look at it, actually see what it runs and look at some timing. So yeah, like I said, mentioned, the very first tool we're going to use, we're going to peel mill the outside, 30,000, the full depth, 30 thousandths per pass on the peel. And then the second tool, we're going to use that 1/2" die pause. This tool is actually going to be running at 4,000 RPMs and 240 inches a minute with a 15,000 step down. It's going to be a total of 10 minutes and 21 seconds to rough out both sides apart. Forgot to mention the first tool does take around 15 minutes. We can save a minute by taking this the lower depth of cuts. I don't know if it's as fast or slower than using the two tools, but like I said, using the index inserts, you should get better tool life, and per index should be cheaper than using a solid carbide tool. But this is things we can play around and get more aggressive and see what can take time. All these feet and speeds I would take with a grain of salt because we don't know how it's going to run in real world. So I stayed on conservative side to make sure it runs. When I read about the 4820, it's pretty soft alloy, so I should be able to get pretty aggressive with it. We won't know how it works in the fixture and the setup until we're in real time. So these times are all going to be taken with a grain of salt. Once after we rough it out with the 1/2" die pause, I like to come in with the QF drill and we'll actually plunge out like you do now, but I'll take some more plunges. We can add or subtract plunges to save time or what we see is necessary. We could probably even make that web thinner, but I found out with the feed mills, if you go the whole way through, it leaves a gnarly burr. It likes to grab tooling, especially on a small feed mill, then hanging way out. Even if we do from both sides, you're going to get a gnarly burr and it's going to grab. So I like not going the way through. We can plunge mill. We can even look at options of drilling and plunge milling the whole thing. I was just trying to keep tooling down, and we can play with those times well. But this is the first attempt, is just, hey, this is how I would do it. We can look at times. If times aren't good, we can review and adjust from there. Also, after we rough it out, we're still going to have the scallops in the corners and scallops on the side. I'm leaving only about 5,000 surface with the feed mill in here. And then these are about 5/8 diameter in the corners that we're leaving that will plunge out the way you guys are plunging out. I'll explain that later. So then our next tool is going to be the die pause again with the 9-degree version with the solid carbide, just to finish roughing out those leftover scallops. I do leave a little bit more stock on this in case you get pushed with the feed mill. Leave about 7,000 side, just on that 1/2" rib. Then I'm going to go there and finish down the sides. When we were roughing that, I was only taking 30,000 depth of cut. We can go much more aggressive with that tool, but I don't know how we'll cut. That was light and fast, excuse me. And then we went down there with only 90,000 step down to finish it, but we can actually go up to 150 depending how much step over we're leaving. The 90,000 will leave a 50% overlap, so that's kind of where I like to start. We can keep adjusting that step down, get more and more aggressive, and try to save time on it. That plunge tool, I forgot to mention, the QF is about 6 minutes to plunge all that out. The finish roughing that step is around 6 minutes, and then the finish the whole way through the walls is about 8 minutes long. Then once we do that, I didn't even spec a tool out for it because I know you guys already have a tool, but we can provide a tool plunged out the corners like you guys are currently doing. And that tool, and this, the way I have it programmed, is taking about 6 minutes per part. So if we look at the total time of the process running, we are right around 53 minutes and 50 seconds to do the entire operation from start to finish on your pallet changers. I don't know where you guys are currently at. We can tweak things up and down. You can take or leave certain parts of the process. We can do some more experimenting. But I wanted to show you guys a quick demonstration what I kind of have worked up in times so you guys can compare to what you're currently doing, and we can go from there and decide what we want to bring in and demonstrate. So if you guys have any questions, I'll be talking to you tomorrow, and we can continue discussion then. I'll talk to you later.